Millions of us type prompts into ChatGPT and Claude every day. We pay $20 or $30 a month, handing our questions and our data over to massive corporate servers to process the answers. We are renting intelligence by the month. But renting comes with strings attached. The subscription costs are climbing. If your Wi-Fi drops, your assistant vanishes. And if you are a developer pasting proprietary code, or a lawyer summarizing confidential case files, sending that data to a third-party server is a massive security liability. That friction has pushed developers and power users to look for an exit strategy. They want to take these language models out of the data centers and run them entirely on their own machines. If you want absolute control over costs and a guarantee that nobody is reading your prompts, the intelligence has to physically live on your hardware. For years, downloading a cloud-level AI was impossible. The obstacle wasn't the download speed. It was a physical bottleneck called the VRAM wall. An AI operates completely inside video RAM. At standard precision, every 1 billion parameters needs 2 gigabytes of VRAM. To run a 70 billion parameter model requires 140 gigabytes. Since a consumer laptop ships with 16 gigabytes, the math simply does not fit. To run that unmodified model, you'd have to buy multiple enterprise server GPUs, spending tens of thousands of dollars just to boot it up. Unless someone figured out how to alter that math, elite AI was going to remain permanently trapped inside corporate server farms. The solution didn't come from better hardware. It came from a software hack called Quantization, using formats like gguf and AWK. Instead of storing a model's weights as massive, highly detailed 16-bit numbers, developers strip the precision down to 4-bit integers. They are essentially rounding the numbers to save space. This compression shrinks the model's total file size by up to 75%. Suddenly, a massive 70 billion parameter model slides easily into the memory limits of a high-end consumer machine. You would expect a massive drop in performance from losing 3/4 of the data, but these models retain roughly 95% of their original reasoning quality. That single mathematical compromise turned everyday desktop computers into viable AI research stations. But compressed math still needs the right engine to run it, and Apple's silicon architecture accidentally created the perfect environment for local AI. Modern Macs use a unified memory, meaning the GPU can access all the system's RAM directly. If you buy a Mac Studio with 64 gigabytes of memory, your GPU has 64 gigabytes of VRAM. It can run massive models that would otherwise require a stack of expensive server graphics cards. Meanwhile, Windows Copilot Plus PCs took a different approach, embedding neural processing units, or NPUs, capable of 40 trillion operations per second to handle everyday AI tasks without draining the main processor. Even with the right hardware, running these models used to require diving into complex command line interfaces and Python scripts. It kept casual users locked out. Then came the wrapper applications. Tools like Ollama let you download and run a model with a single terminal command. LM Studio wrapped the entire process in a clean, visual interface that feels exactly like using ChatGPT. This convergence of compressed math, unified memory systems, and one-click apps has dismantled the gatekeepers, moving local AI from a technical experiment to a practical reality for anyone with a laptop. With the hardware and software barriers gone, major AI labs began releasing open-weight models, engineered specifically to be downloaded and run locally. Today, models like Meta's Llama 4, Alibaba's Qwen 3.5, and Google's Gemma 4 reach frontier parity. They can write code, analyze documents, and follow complex logic just as well as the APIs we use to rent. For advanced math and specialized scientific reasoning, powerhouses like DeepSeek R1 and V3.2 are pushing the absolute limits of what consumer hardware can process. We have crossed a critical threshold. Artificial intelligence is no longer strictly a metered service monitored by a tech giant. It is now a sovereign asset, a tool that lives privately and permanently on your own desk. But while local AI has conquered everyday tasks and data privacy, the tech giants haven't stopped building. Their data centers are expanding to push the absolute physical limits of what intelligence can be, and that requires hardware you could never fit in your house.
Thank you for watching. For more professional AI insights, remember to like this video and subscribe to AI Corecast.